factors is very easy to understand. They are affecting the rate of oxidation. And we will be mentioning some very detailed later on. Okay, what are the lipids oxidation going to happen? What are the 3 steps? The 3 steps very similar to what we learned before, which is initiation, propagation, and termination. So the very easy 3 steps. Initiation. Okay, what is the initiation going to happen? This happens initiation. I'll give you an example. Okay, we just use like routine and the conclusion formula. This will become oxygen, hydrogen. Fatty acids products, unsaturated fatty acids, will be split, release. This is called free radical and hydrogen atoms. Where is this going to happen? This happens usually is in the place next to the double bond. There is a terminology for that. Let's say this is a fatty acids. It's very easy happen is right here. Not this double bond. The position of this is a carbon atom next to the double bonds. This is called olefinic position or olefinic carbon. And we had a table right here tells you how easy or how difficult it is to have the hydrogen abstracted from the olefinic compound. So you can see if it's a polyunsaturated fatty acids, less energy is needed. There's only 64 kcal per mole. If it's saturated fatty acids, it's going to be much more energy. Okay, mono a little bit higher than polyunsaturated fatty acids, less than saturated fatty acids. If it's a short chain, usually it's need more energy. Okay, so this is gives you a conclusion table how difficult and how easy to abstract the hydrogen from an olefinic compound. This is, of course, it measures the energy requirements. So the second step happened is propagation. Propagation. Now, what's going to happen for propagation? This guy comes out. This free radical will find an oxygen. Then become what? This guy, we gave them a name called peri-oxidized or oxido radical, or APIC radical. Peri-oxido radical. See, peri-oxy radical, P-O-X-Y. Well, we can say polyoxido, I will say peri-oxo radical. Okay, when this guy comes out, they will going to find another fatty acids. Then what's going to happen? And release a free radical. This is hydrogen peroxide. Okay. And this guy could be repeated right here. And this chain could go long, 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 and happen about polymer, kind of. Not really a polymer we talk about in the carbohydrates. It's like fatty acids, a long chain will be generated. And the last one is termination. Now, what the termination means? Which means a free radical has been stopped, not free anymore. So it could happen. Two free radicals become a free radical chain. And this free radical with perioxo free radical becomes RO2R. And then multiple perioxo will be combined, become a chain. Okay, that's called the termination. So this is a procedure. We say it's very abstracted. I'm going to give you an example later on to explain this to you. I use oleic acids to explain to you what it really talks about. So we first know the overall picture about this. Okay, initiation, propagation, termination. Now during the propagation process, usually the perioxy radical is dominant there and do the chain again and again. So initiation is free radical release, termination. Basically now no free radical is existing. So yielding unactive products. Okay, this slide which tells you how easily will be happened auto-oxidation. Now we already know it depends how unsaturated it is. So stearic acids, let's say the rate is 1/1. If it's become linolenic acids, which is 18-3, the degree of the degree and the possibility of happen auto-oxidation will be increased almost 2,500 times, which means dramatically increased with the increasing of the unsaturation. So 3 double bonds in the 18 carbon fatty acids is 2,500 more chance will happen for auto-oxidation compared to stearic acids, which means no carbon, no double bonds here. Okay, now other things I just mentioned, the position of the double bonds really matters. Non-conjugated more reactive than conjugated. And the position, which we talk about SM position, specific position, number 1 or 3 is more reactive than 2, which means at the bottom or top is more easily to react happen auto-oxidation than the position at SN2. Third is the temperature. If we do the frying, the temperature is reached as high as 180 to 100 degrees Celsius, which is accelerates the oxidation. So obviously, you know that the frying is the process to oxidation, will generate the final is the oxidized products. Okay. Okay, how do we know our oxidation is happening? We have 3 index to tell us the oxidation, auto-oxidation is reactive. Therefore, we have this curve. 3 chemicals we really care. It all happens like this. Number 1, peroxide. Okay, once the peroxide value has been increased, we know the initiation of oxidation. So this we know, the initiation is started or initiated. However, we cannot be using peroxide amount to determine whether really happens by auto-oxidation. If we measure it very low, does not mean it's really nothing happened, because the peroxidized curve is kind of like a bacteria growth curve. At this stage, the perioxidase in the initiation and the propagation, actually they'll increase dramatically, but you're not going to measure it at this moment. Let's say right here. You're not going to measure any amount, it's very low, but it's do started to do the autooxidation, especially right here. Okay, so you can say we measure the amount of peroxide is low, we say it didn't start. Now once the peroxide amount is very high, actually you will see it's go to the stationary phase and also start to decomposition. So be careful about that. This also we know the initiation of the autooxidation. Okay. Second way is the benzene. Benzene. If we measure a high amount of the benzene there, what means? This is used to measure aldehyde, which means aldehyde is being generated. That means the product started to have off flavor. Okay? Because we already mentioned it here, the peroxide, hydrogen peroxide is unstable. This is not really contribute for the off flavor of the products. And when you have a hydrogen, when you have an aldehyde generated, then measured here represent as an increased amount of the benzene, benzodiene, that means the aldehyde generates or flavor started to generate. Last, how do you know if it's really almost complete the autooxidation, which means the product has been completely oxidized? If you see there's acid generated, typically it's formic acid generated. If an oil products, you have a formic acid generated, that means it's completely auto-oxidized. I'm not going to go bottom of that one. We have textbook which is mentioned some reaction function equation. You can take a look. So, since we mentioned it here, we already mentioned peroxide formation is not a good indication to see the progressive, to see the whether or not it happened also oxidation. So which index we use to measure? We use the index called tau tox value, TOX, tau tox value. This is the value to measure the amount of the products generated from the primary, secondary autoreaction. This amount we rarely know. What's the level it reached during the autooxidation? Because there is two components here. The Totox value is 2 multiplied by peroxide value and the Einstein value. The Einstein is usually to measure second oxidation products. So industry, they use in Totox value to measure the progressive of the autooxidation. Peroxide only knows the initiation. Now here mentioned again, if the formic acid happens, indication the end of the introduction process. Okay, I'm going to give you an example to explain this whole process. Because when I started to teaching at the beginning, I find that when you read it here, it's kind of very difficult to understand. This is actually described it very briefly. So I added this one there. I can explain to you. This is also very briefly mentioned. This description is kind of very confusing you, so I use an example to explain to you. So first of all, let's give you an example of oleic acids. Okay, oleic acid is 18 column 1. 18 carbon atoms, 1 double bond. Okay, what it looks like? We just say it's very have a double bonds. 1, 2, 3, 4. Go. Switch. This will be here, which is we're going to have 7. There goes CH3. Okay, this is one double bond. Let's count. 1, 2, 8, 9, 10. Yeah, add 8. So that's 18. Okay, right there. This is oleic acids. After lipid oxidation, the reaction happens in the subtraction of 8th position, or right here, or happened 11th position, 9, 10, 11, right there. So it will be generate a 4 isomeric hydrogen peroxide, right there, and these are 4 isomerized products with free radical. And this phenomenon causes renaissance. This is just a conclusion. Okay, then tells you oleic acids happened in the carbon position 8 and 11, then generate these 4 different types of the isomerized hydrogen peroxide. But what really happened, it didn't tell you. Then our textbook just gave you all these 3 conclusion type of the description. So I'm going to tell you the detail is what happened right here. Okay. So what's going to happen? The first position, when you happen, this should be described by CH25, then give you CH. And goes here. Okay? What is going to happen? This position is easily to take it out. Become a free radical. This oxygen is right there, okay? It's gone. This is the first step, initiation. If there is heat, light, or metal, this will happen. Once this happens, this part is called alkyl radical. Okay, then what's going to happen? Oxygen will go there. So, 1 oxygen there, 2 oxygens there. What is this called? Peroxy radical. This part, the whole part, become peroxy radical. E-I-C-A-L. That's a peroxy radical. This peroxy radical will be attract hydrogen from the 2nd position or from the 3rd position. This could be attracted from here or from here. So what happened? We'll have another one attached. Then this whole process, at this position, we move this out, make it a little bit clear. This whole process right here, this is become hydrogen peroxide. And what I'm showing you here is just one example of these 4 isomers. Each of these isomers has a separate reaction like what I described here. This is just one example. Okay? So once this hydrogen peroxide generates, which is we talk about here, what's going to really happen? Then we go from here. Okay, once this happens, then we move all these up, okay? This guy gonna be cut. Okay, then becomes what? Hydroxy radical. These type of stuff you can understand is a byproducts. It's not a contribute to any of the flavor change. Okay, once this is gone, this becomes what? How about this area, this place? What we call it? This is called alkoxy radical. Okay? Now, what's going to happen? They're going to start to have cut. Then directly cut it from here. This is called a hemolytic scission. Hemolytic scission. You cut it from there. They cut it from here. Become 2 parts. This part with glycerols, we call it glyceraldehyde. This part we call it glyceraldehyde. This is non-volatile, which means this part is not contribute to the final of flavor. Then what's really happened is right here, is this section. This section right here is what we are interested to see. Okay, which reaction will happen? This happens, a double bonds migration. So at the end of the day, what products is generated? This is the final product. This is called aldehyde. Okay, this is aldehyde. What is the name for this aldehyde? If you learn in the chemistry, organic chemistry, 2-ono then central. If you want to look at it, densanol. This I know it's Spanish words 10, so densanol. What that means, this 2 means the double bond position is carbon number 2. Uno is 1. This Spanish word means 10. So you add it together, this means 11 carbon. And you count 1, 2, 3. Add 7, 10, 11. That's 11 carbon. This is an aldehyde. Okay? If you really want to use an organic chemistry terminology, 2-ono densanol. That's called. UN-ono is 1. Densanol is 10. You add it together 11 carbon. Now, this is the aldehyde. Once this aldehyde is generated, it has two more reactions could happen. They could be go ahead to find another chain right there. So go there and add the one oxygen. This becomes alcohol. That's why the alcohol is a final product sometimes. Lipids oxidize, you smell it like the wine sometimes. And this could be reacted by itself. Then what happened? This generates. So finally will become this is ketone. But ketone does not always happen. Okay? That is the whole process of giving you an example of when oleic acids will be happening from the beginning to the end. And usually at this moment is the third stage. So, by all means says, oleic acid, each of these isomerization, they could be happen with this type of reaction from the beginning to the end. Each of them have their separate and specific one. Okay? Now, these, what I draw there, actually described in our textbook very clearly is right here. But they use just R to do the example. It's very abstracted, which means if you don't know this detailed reaction, you're not going to understand this very well, even difficult to remember it. So when I draw everything here, you can come back to read here what happened. Okay, this is happens right here is the hydrogen peroxide. Actually, this process is by Kinney, described in 1962 in his paper. So this is going to be then this RCHOR, which is a hydroperoxide. Then they split, become alkoxy radical and aldehyde. This is what I described right here. That's aldehyde. Then this aldehyde could be abstracted a hydrogen from another molecule. What I said, if there's another hydrogen here, even the second or third place, they could be attracted to hydrogen, they become alcohol. And then they also could be reacted by itself, become a ketone. But this is even further misunderstanding because this misprinted. That should be here. That double bonds O has to be moved to here. Okay. So when you first read it, you never understand it very well because